Chapter 6, Systems of Equations. One more chapter on linear functions. You have a foldable to cut out. Make sure you cut out the side that has the directions so that you don't cut off any of the directions. These two-sided foldables are not exact. So make sure you're looking at this side when you cut it out. Solving systems of linear equations, there are three methods. We have a graphing method, substitution method, and elimination. Graphing method will be 6.1. Substitution method is 6.2. And the elimination method is 6.3. So we're going to be using this foldable for a few sections. Starting with the graphing method, graph both lines that we used in Chapter 4. Chapter 3, we have some different methods. I have standard form. I'm going to put this into slope-intercept form. This is my second equation that's in slope-intercept form. And I'm going to change standard form into slope-intercept form. I want to have a positive y. Because y is negative, I'm going to move it to the other side. And then I'm going to shift the positive 4 over to the left-hand side. We have y equals a 2x. When I shift positive 4 to the opposite side, it becomes a negative 4. Using slope-intercept form, you start with your y-intercept and then use your slope to rise and run. My y-intercept is negative 4. And then my slope is 2, so I'm going to rise 2 and run 1. Rise 2 and run 1. And I'm going to do this a few times because I'm looking for where my lines are going to intersect and I want it to be exact. So I'm just going to keep rising and running until I've gone a few times. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. We'll start with that. Because we have a system of equations, we need to make sure that we're graphing and labeling our lines correctly. My next equation is y equals 1/3 x plus 1. My y-intercept is 1. And I'm going to rise 1 and run 3. Rise 1, 1, 2. This is the point where they're going to intersect. I just landed right there. Rise 1 and run 3. The point of intersection is 3, 2. Graph both lines. Estimate the intersection. The word estimate is not really good for when you're trying to find exact solutions. Here we see that we got exactly 3, 2. State the ordered pair. What happens when your solution has a fraction? How do you know what the fraction is going to be? If you are 2/3 of the way or 3/4 of the way, and depending on how you graph it and how you try to be exact, how do you know exactly what that fraction is going to be? That is why the graphing method only works when you get exact values. If I get fraction values, then I need to switch to substitution or elimination for a method. If I get fraction answers, I'll know exactly what those fractions are with these two methods. The graphing method is only good when you get exact values. We can check our solution. It says to state the ordered pair, 3, 2. Check your answer. We're going to check our solution into both of these equations. It needs to work for both of them, not just one of them. We'll start with 2x minus 4 equals y. And we're substituting that x is 3, y is 2. Y is 2. And we get 6 minus 4 equals 2, and we get 2 equals 2. It works for that equation, and now we need to check it for the other one. We have y equals 1/3 x plus 1. Y is 2. 1/3 times 3 plus 1. 2 equals 1/3 times 3 equals 1, and plus 1, we get 2 equals 2. This solution works for both equations. Therefore, it is a solution for the system of equations. You're going to have to tape your foldable in sideways. You could tape it in this way. There's just enough room. Either way. Be careful about how much tape you're putting on these sides. You still want to be able to write on this.